All right, so in this video, we're talking about maximums and minimums. Maximums and minimums, some people call them extreme values. Extreme because they're the highest point on the graph, the lowest point on the graph. The highest, the biggest y value, and the smallest y value. And so we're always looking for extreme values. Some people call them extrema because that's the plural of extremum. Maxima is the plural of maximum. Minima is the plural of minimum. But I digress. Maximum minimums are just looking for what's the highest and lowest point on the graph. Is there a highest or lowest point on the graph? And so we're going to talk about in this course a little bit more so in calculus that we have different types of maximums and minimums. So we're going to talk specifically about relative maximums and minimums. And relative maximums and minimums are: is there in a neighborhood of points, is there a point that's higher on the graph than all the other ones? So when I look at this one, when I'm looking at this graph, I should say, when I'm looking at this graph, I notice that the graph goes up forever to the left and it goes up forever to the right. That means there's not going to be a maximum point because it's just going to go up forever, right? There is never going to be a highest point because it keeps going up, 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 up. However, there is a lowest point. And this point right here, we're going to call two things. It's a relative minimum, or just minimum, and it's also an absolute minimum. So let's talk about the difference between those two things. A relative minimum is a point that is low compared to the other points around it. Here's a good example of a relative minimum. Here's a graph, looks like a W, right? This point right here is a relative minimum. It's a relative minimum because compared to the points around it, it creates a dip, right? There's a valley in the graph. But it's not the lowest point on the graph. The lowest point on the graph would actually be over here. That's an absolute minimum. That is the absolutely lowest point on the graph. This is a relative minimum. Relative to the ones around it, it's a low point. But this absolute, would also be a relative point. So a point can be relative and absolute, minimum or maximum, either way. But I can only have one, right? There can only be one lowest y value. And so when I'm looking at the graph that we're given, this point that we're given, this graph that we're given gives us a lowest point. So it's a relative minimum because compared to the points around it, it creates a little dip. But it's also the lowest point on the graph. So therefore, it's the absolute minimum. And the absolute minimum is actually talking about the y value. So the y value there is negative 2.25. So we're going to say that there is a minimum of negative 2.25, but it occurs at x equals something. So the minimum value is talking about the y value. And now we're going to say where it occurs. Well, it occurs at 0.5. So at 0.5, that is the absolute minimum to this graph. So you can identify minimums in terms of relative or absolute. Some people call them local and global, but I prefer the phrasing of relative and relative to the points around it. It is the lowest point, but it is absolutely the lowest point out of the whole graph, and it happens at x equals 0.5, but the actual minimum value is negative 2.25. Now, as for the maximum, we said the graph goes up forever, so there's never a highest point. And so I'm going to say there is none because there is no maximum, relative or otherwise. By the way, in that example that I drew over here, this point right here would be classified as a relative maximum, but it's certainly not the absolute maximum because the graph goes up forever on both sides. So there's never going to be a highest point, but relative to the ones around it, it creates a little hill. So that classifies it as a relative maximum in the example that I drew over here on the side. But in the graph that we're talking about, there are none. There are no maximums at all.